Hey Managing Hero, Jay here. Back in Rock 7, we introduced the SurfMax, and it really made my head explode. There's so much to think about. So I'm back here in Minneapolis, and I wrangled Stephanie to bring her down to the production floor to explain some questions I had as I was researching this thing. Stephanie, thank you.
Hey Jay, good to see you again.
It's good to see you again back at home.
Mm-hmm.
Okay, so Rock 7, we talked about the SurfMax. You were explaining that guy to me.
Mm-hmm.
And I did a little bit of research, and I saw that there are some systems out there that do some similar things, but they use grayscale as a defect channel. Can you explain to me what grayscale is, kind of the methodology behind it, and what that shows, and maybe some other stuff?
Sure, yeah. So conventional visual inspection very often uses just the grayscale channel.
Okay.
And the grayscale channel is observing changes in white light reflectivity on the surface of the part.
Mm-hmm.
So it helps us to see imperfections related to maybe changes in color or discoloration on the surface of the part. We're going to look at an injection molded part with what we call a dot imperfection.
Okay.
And it can also help us observe certain contours on the surfaces of the part.
Got it. So if I think I hear that right, is what we're looking for, similar to how I use grayscale in metrology, we're looking at changes in lightness, right? From dark to light.
Yeah.
And the highest contrast possible is what we get, right?
That's right.
Kinda
Yeah,
like
let's
this
take a look at the example I have here. So this is an injection molded part, and you can see on the surface here, we have this little sort of dot. Yeah, you can see there's something that's sticking out there. So if we apply our algorithm to this grayscale channel, it's going to pick up on that discoloration, or that dot defect right there.
Because the defect kind of shows up as a color contrast.
Yeah, exactly.
Makes total sense. Got it.
Yeah.
Okay, but what if there are other defects out there that don't show itself like that, right?
That's a really good question. So I have a few examples. Something that's really unique about SurfMax is we actually use 3 channels of information. So that allows us to see a lot of different types of defects.
Okay. The
next example I have up here is a contamination defect. So we're looking at actually a fingerprint on the surface. So this is our grayscale channel, and you can really kind of faintly see the fingerprint on there. There's something, but it's not super contrasty. Mm-hmm. It's really not popping in this channel. So we're going to take a look at what we call the gloss channel. And gloss is looking at the way light scatters off of the surface of a part. So it's going to highlight textures, non-uniformities. In this case, contaminations are really going to pop under this channel.
Okay, so you're looking at, to get into a vernacular that I can understand, you're looking for like when I go to the paint store and I can choose like a matte paint or a gloss paint that has a totally, like, light bounces off that different. Is that what we're looking for?
That's exactly what we're talking about.
Okay, so
here.
Matte versus glossy is this channel, right?
So let's take a look at the gloss channel and see what happens to that fingerprint. Yeah.
It's totally pronounced.
Yeah, it really, really pops in this channel. And that's important, especially for contaminations. You know, this part could be easily rejected if we weren't able to recognize that this is just a contaminant, and it can be cleaned off the surface.
Right, right.
So if I apply our algorithm now to the gloss channel, it's really going to pick up on that fingerprint defect for us.
Yep.
So last but not least, let's talk about the slope channel.
Yeah, you said a third.
This is the third channel. That's right. So I have a third example for us up here. And to give you a little bit of background on what slope is looking for, it's actually looking at the angles of our surface and observing how they change. So it's really good for observing form-related imperfections. You know, certain processes like painting can cause like an orange peel where you get like a very bumpy sort of surface. It's great at picking up on like big scratches and dings and dents, those sorts of things.
So you're actually real time then calculating a nominal flatness and then comparing other angles?
Yeah.
Oh my gosh.
Spot on. And we're doing it in real time, so it's as quick as that. So In this example, we're looking for what we call a wrinkle. So this happens, could be in a coating or a painting process when something dries.
I don't see anything here.
Yeah, this is our grayscale channel. You're not going to see anything.
There's nothing
really
here.
In this channel. Let's take a look at the gloss and see if we detect anything there.
I see the exact same as I saw in grayscale.
Not really. So let's go take a look at the slope channel. And what you're going to see is up in this corner, you see like a really faint sort of waviness. So that's that form error we were talking about.
And there's a little bit coming in here. Is this what I'm looking at?
Yeah, you got it. And if I apply our algorithm to that, our inspection,
there it is. Oh,
it's going to pick up on that defect for us.
So that might be like a coating imperfection in the curing process or something that...
Yep, it's causing kind of this waviness on the surface. So it's very easily detected by our slope channel.
Wow, so I think I'm seeing that it's not enough to have grayscale. So you really have to do...
Yeah, it lets us see so many more types of defects and to correctly classify what types of defects they are, whether it be a contaminant or some sort of form error or a scratch on the surface.
Okay, Stephanie. All right, my mind is spinning right now. You showed me a defect here that I could barely see even with the slope channel. So how does this algorithm that you've just turned off and on kind of interrogate whether that was enough to be a defect or not? Because man, even with the help of the slope channel,
totally sensitivity is super important, and our algorithms can be as sensitive or as least sensitive as you need them to be per your production requirements and your quality requirements, which are naturally going to be different to every industry. So let's take a look at some sample reports that I've prepared here. So this is a different example I'm pulling up, and you can see we're looking at some scratches on the surface of this demonstration piece. And this is our find stage. So this is actually detecting the defect on the surface. So we're applying that scratch algorithm. But what I can do is I can adjust the sensitivity. So
this is 20%.
Yeah, we're looking at 20% on this one. And you can see a little bit of the defects are being picked up on, but not everything is being detected at 20%. So if I go down to our next report page here, I've adjusted the sensitivity to 50%. So as you can see, there's a little bit more yellow. So we're detecting a little bit more. And again, if I adjust it even further to 80%, you catch a lot more of those imperfections on the surface.
Yep, so you can kind of choose the sensitivity of what your based on what your threshold is, what you're measuring.
Yeah. And so taking this a step further, we can also then take this and we want to classify our segments as either okay or not okay defects, because we found a lot of scratches on the surface here, and they may not all be bad. Some may be acceptable. So on my final report page, you can see that we're applying the sensitivity to the algorithm, and we have some green, so those are okay segments. They're not severe enough to cause a reject. We have some yellow, which are maybe borderline. They're a little more suspect areas. And then we have red. Those defects are too severe and they cause reason for rejection of this part.
Okay. So, all right. I understand. I think I'm beginning to understand how it's important to not only have new tools to see the defect, but you also have to have tools to kind of cut out what is not just sensitive to, but actually even interrogate all of that.
Yeah, that's right. I mean, every part is going to have imperfections on the surface of the part. So we have to be able to sort out what's an acceptable imperfection and what can we qualify as a reject, a really defective part.
That is mind-blowing, because if I recall correctly, we take hundreds of images per minute, right? So we're doing this analysis.
And this is all going in real time as our parts are going through. It takes no time at all.
So again, so for me, I definitely have to rewatch again Rock 7 to hear more about some of the benefits of the SurfMax. But I really do appreciate taking the time to explain, because I mean, to me, it's one thing to have someone list the benefits to me, but to actually be able to wrap my arms around this is what grayscale is and this is what sensitivity means really helps me kind of understand. So thank you for...
Yeah, good. I'm glad we could do it.
It's great. I might have more questions. Can I wrangle you in again?
Totally.
Awesome. Awesome. Stephanie, thank you for doing this. Appreciate
Thanks,
it.
Jake. Good to see you.
Good to see you. And for you out there, hope you enjoyed my nerdy journey. Stay healthy out there. And we'll see you next Thursday.